Hi, I'm John from UNIXSurplus, and today we're going to be looking at our 16-bay 4U storage servers. These are all SATA storage servers with 16 bays of hot swap SATA drives in the front, redundant power in the back, and a standard PC server board. We have systems made by Rackable Systems, which is the top system here. Then we have other ones made by Supermicro, which are also called Pogo Linux servers, and Pogo is the OEM reseller for Supermicro. So let's take a look at some of the features on the front of the units. The Rackable Systems has an LCD in front, you've got your power switch, and you've got remote serial management. The Pogo Linux has both either floppy and CD in front, serial console, USB for your keyboard too as well. Each system has a hot swap bracket. You can pop out 16 drives. This Pogo Linux machine right here has 250 gig SATAs right now. This is a little bit of a deeper bracket to give a lot of good airflow, laminar airflow. The Rackable system, we don't have hard drives in it, but I can pop it out right now to show you what the backplane looks like inside. You can see here that you have 4 SATA hot swap connectors. This is 4 independent horizontal backplanes. You also have different redundant power channels too, where this power set of drives here has a separate power bus than these here. So if one drive falls over here, you have redundant power over there. This is called redundant power buses. Both these servers have this feature of redundant power. Let's take a look at the back of the machines. The Rackable system is on the back here. The Rackable's actually got a nice thing. It's an 18 drive bays. It has 2 extra hot swap drive bays here that are SATA that you can put your boot hard drives in. So if you wanted redundant operating system OS boot drives, it's here in the Rackable. Now the other features that they have plenty of PCI X slots. You can tell by how many slot covers what the RAID configuration is. Each of our servers and each of our configurations online have different RAID controllers in it. So you have to check our listings to know what is in each one. But you can see here, this is a standard 3-wear RAID label right here. You can see the model right here is an 8506. The 9500s don't have the sticker anymore, they just have that green pass thing. Each of the servers has dual gigabit Ethernet. You can see that the Rackable also has management Ethernet, USB, keyboard, mouse, video, everything you need to boot. So let's take a look at redundant power. The Rackable system uses 2 redundant power supplies. Each one here is 530 watts. So you got a lot of power here to run the whole machine. The Supermicro uses 3 power supplies, so you have N+1 power. So let's open them up and take a look inside the machines. A little hint, anytime you see these push buttons, you usually have to go forward first to free up the lock so you can get the push buttons free. Then the machine will open right on up. You can see here, this is our Rackable system that we're looking at right now. Every machine is going to have a RAID card, dual processors, power supply, fan trays, and then a SATA cable harness system like this. So let's take a tour of inside the machine. Every machine is built on a RAID card. This is what allows you to make one volume and put all those small hard drives into one large hard drive. What's really, really important is the battery-backed RAID card. This allows you to enable write caching, so you can write to fast memory first before you write to the RAID array. We'll talk a little bit more later about RAID arrays and why you need write caching. But this is a 3-wear AMCC, LSI Logic, all of them are the same company, RAID card. You can also see some common features. There's 2 processors per machine, memory sockets, and then a nice cable harness that connects everything. This Rackable has a separate boot hard drive running off the motherboard here for your boot SATA hard drive. So this is inside the Supermicro Pogo Linux machine. You can see that this one uses 2 RAID controllers. These RAID controllers will not allow you to build one contiguous volume. Because they're 2 separate RAID controllers, you have to divide it into 8 and 8 hard drives. Another feature about these RAID controllers is they don't have the multi-lane connectors. This is just a little bit different as far as the cable harness. But if you plan to change the RAID controllers, you need to go to individual SATA connectors. Each of these has 8 SATA ports. The other one we looked at had 16 with the higher density multi-lane connectors. This thing here still has 2 processors, just like the other system. The system board itself is not made by either of these manufacturers. This one here is a Supermicro system board. You can see here that it still has a place for an internal boot hard drive. That's so that you can have your RAID array and your redundant storage and your software boot totally separate. This uses an IDE or PATA-based hard drive. Same features that you'll always see with the ECC redundant memory, 2 processors, and a high-end board. Typically, Supermicros and tie-ins boards are used. We also have some featuring PCIe slots and Intel system boards as well. Plenty of redundant fans in the Supermicro. You have your boot CD-ROM, floppies, and everything else. You have your redundant power buses coming out to each system. You also have on board your RAID key for these Supermicro. This allows you to do remote management of your RAID array. This communicates via software drivers to your operating system if the RAID array needs any type of service. So let's talk a little bit about RAID data. There's different RAID levels. There's RAID 5, RAID 0, and RAID 1. RAID 5 spreads data across 1, 2, 3, 4, 5 hard drives. It takes typically that used to mean that you'd have data on 4 hard drives, 1, 2, 3, 4, and then your 5th would be your parity. Right now, RAID 5 has distributed parity, whereas this drive has block A, data A, data A, data A, and then this drive has parity A, whereas then you would move it so that this drive would have data B, data B, data B, data B, parity A. And what that does is it distributes your parity across any hard drives. So if you lose any one hard drive, you can recover. So that's RAID 5, and that spreads data across 5 hard drives and allows you to recover if any one hard drive fails. Typically, if you see this, you see 1, 2, 3, 4, 5 hard drives, one hard drive is going to lose parity. So you're going to lose out of 80, you're going to have 80% data storage. So that's pretty good that you get a lot of data storage on your hard drives and you only lose one hard drive out of the whole array for data. Also gives you all the benefits of RAID, where you're reading from 5 hard drives at once and you write to 5 hard drives at once. That moves the data very quickly in and out. The real loss on this is that you have to calculate that RAID parity and which drive you're going to write that parity to. But that's all accelerated by the hardware RAID controller there. So let's take a look at a different RAID. There's RAID 0, which was actually no parity. And that was striping across all hard drives. Okay? So that means that you don't care, you just read and write and read and write, and you don't care about parity. If you lose any one hard drive, you're going to lose your data. However, they combined that with RAID 1. And RAID 1 was just 2 hard drives mirrored. This hard drive is identical to this hard drive, which means that when I want to write, I have to write to both hard drives, but when I want to read, I can read from both hard drives, since I have 2 copies of the identical data. So it gives you twice the read bandwidth with data reliability if you lose any one hard drive. Well, what about that? That only means that you get 50% of your data, so that I only get 250 gigs on that hard drive, even though I have 2 250 gig hard drives. So RAID 0 is RAID 1 is very, very fast, but you lose 50% of your capacity. So how does that work though when I want to put 16 hard drives and get that super read speed? Well, you did tiered RAID. You did RAID 0, 1, which is tiered RAID. So I have a bunch of mirrored pairs, and then I do RAID 1 across all of those to distribute my data. I get the data integrity of RAID 1, I get the speed of reading twice as fast from RAID 1, and I get the speed of then multiplying that by how many pairs. If I have 16 pairs of hard drives in this machine at RAID 1, 8 of the hard drives are 2 mirrored pairs, so I lose half my capacity, but I get 16 times the read bandwidth out of my read volume, and I get the full parity. So that's really popular now, with disk drives becoming very inexpensive. Another note about hard drives is because a lot of our customers want to use their own hard drives. It's really important to use all matched hard drives that are enterprise grade. If you use desktop level hard drives like these WD Caviar Blues, they're good hard drives, however, they're not enterprise certified. Usually they have a smaller level of memory. You can see by the size of the circuit board on these, it's much smaller. You're not going to have as many chips. You're going to have less read cache, and you're going to have a problem where the drives will spin down or go silent on you while your computer's still up. They go into a power saving mode. The other thing is the non-enterprise level drives don't have the same read performance based on the outer side of the cylinder of the drive or the inside. You have a disk spinning inside here, and you get more performance the faster you go to the edge. So enterprise drives are guaranteed performance from the inside to the outside cylinder. That's important when you have a RAID array because you only can read as fast as your slowest hard drive. So when you're selecting your hard drives, it's important to use all matching sizes on the same RAID array. You can make a RAID array of 250 gigs and then another RAID array of 500 gigs in the same machine. That's perfectly acceptable. But don't try and mix and match different drives with different write performance characteristics. What this does is it allows latency when the disk is spinning around. For if this hard drive needs to wait, you have to spin one full rotation, which goes at 7200 RPM, which is milliseconds, for you to read the next block. So if these 3 hard drives have read, you have to wait for this hard drive milliseconds to read your data. That slows things down. So that's a configuration where you have 5 hard drives in RAID 5, and you stripe the parity across the 4 hard drives. There's also RAID 6, which is also sometimes called distributed RAID parity. That would be where you would move the parity onto different disk drives. RAID 0 is typically just striping across everything, and RAID 1 is mirrored pairs typically. So a lot of people, when you select RAID 0 or 1, it's the same thing because you're going across mirrored striped pairs in many disk drives. If you have any questions about which RAID to select, you're more than welcome to call us at any time and we can help you analyze your situation. So that's a tour of our 4U 16-bay SATA hard drive storage servers. These are great machines if you want to run your own NAS server or any type of filer system. You can order any of these machines at UNIXSurplus.com or always call us at 877-UNIX123.